Hi, good morning, students. This is Harsnath Sukla, and today's topic for class 12th is types of function. We already discussed exercise 1.1 based on relation. So, in that, you already know about the reflexive, symmetric, transitive, and equivalence relation, whatever. I already completed. So, today's topic is types of function. So, before doing type of function, we are just recall the class 11th function. So there are definition, domain, range. So we just recall it. So first of all, function. Let f from x to y be a relation, then this is said to be a function if for each x belongs to x there exists unique y belongs to y such that y is equal to fx. That means if we consider y is equal to x plus 2, then you know very well for each value of x, that is if you take x is equal to 1, then y is only 3. There is unique value of y. There is no other value of y at x is equal to 1. That's why it is known as a function. So in this section we just going to discuss types of function. So for that we know the domain and range. You know very well, if f from x to y be a function, f from x to y be a function, then subset of x is defined as domain of f. Domain of f is nothing but subset of x. Range of x function is range of function is range of f is defined as subset of y, and the whole set y is defined as the codomain. This is very important. Codomain. The set y is defined as codomain. This is very important for that particular exercise. So now we are going to discuss first type of function. This is very important, one function. See, one function or injective function. So let we have given a function y is equal to fx, then it is said to be 1 or injective function if for each x1 x2 belongs to x, fx1 is equal to fx2 if and only if x1 is equal to x2. That means either x1 is equal to x2 implies fx1 is equal to fx2, or fx1 is equal to fx2 implies x1 is equal to x2. Then this is said to be one function. For example, we can see, let us consider y is equal to x plus 3. If f from r to r, that is real number to real number, this is a real valued function. If we consider for each x1 x2 belongs to r, we have fx1 is equal to fx2, then x1 plus 3 is equal to x2 plus 3, and you know very well 3 cancelled out, so x1 is equal to x2. You see, you can take fx1 is equal to fx2, then x1 is equal to x2, then this particular function is 1 from r to r. Similarly, second function, surjective function or onto function. Surjective or onto function. So for this, from definition, a function f from x to y is said to be onto or surjective if every element of y is the image of the sum element of x under f, that is for every y belongs to y there exists x belongs to x such that fx is equal to y. That is, for every y belongs to y there exists x belongs to x such that fx is equal to y. Okay, so your homework is just you learn the definition of this particular function, and then we shall discuss the questions based on this. Now next type of function is injective is completed, bijective, surjective is completed. Now bijective function or 1 1 onto bijective function or 1 1 onto bijective or 1 1 onto function. So for that, if f from x to y, if f from x to y be a function, then it is said to be bijective function if f is first 1 1 and f is onto. That is, if a given function is 1 1 and onto, then the particular function is known as 1 1 onto or bijective function. So one thing is also important here. I already talked about the codomain of the function. So for second type of function 1 1 onto, that is onto function, that is surjective function, the most important thing is if range of the function is equal to codomain, then the given function is what? Onto function. It is given here also. See, remark, if f from x to y is onto if and only if range of y, function is y, that is codomain. Range of function is equal to codomain. Okay, so on this also some examples are there, you can do it. Here the mapping is there. This means x, y, x1 x2 is the set 1 2 3, here a b c d. So f1 is the function, which type of function you can find out. F2 is which type of function, either 1 1 onto or 1 1 onto bijective. Okay, so whatever condition is fulfilled, that particular function f1 and f2, it is already given here, you can find out. See, the function f3 and f4 from 1 point to 3rd and 4 are onto, and the function f1 figure 1.21 is not onto, as element e belongs f in x2 are not image of any element. E has no image, that's why this is not onto, but f3 and f4 are onto because every element has image. See in this figure, f3 and f4, every element has image. Every element has image. Every element has image. Okay, so and E has no image here, so E is not an image of any particular function. So please do it. Thank you.